Alright, hey everyone, this is going to be my first official video, and today I'm going to explain to you some of the primitives involved with AI agents, particularly agent harnesses. And then I'm going to give you a demo of using Pi, the agent harness coding agent, with Ollama locally to build just very simple API endpoints locally in Rust and Golang, just to see how it does out of the box. So the first thing to understand is, how do you stop depending on a cloud AI? So AI, artificial intelligence, overly simplified word to mean the math involved with how your brain fires neurons and synapses. So remember, AI in today's terms is really just large language models. Generally speaking, AI is really more just math, and Bayesian and Gaussian math on being very predictive and forward thinking. So it's math, and particularly LLMs are based on neural networks and deep learning and reinforcement learning and training that neural network to be very precise and probabilistic on the tokens you want back. A token is, I think one token is roughly 4 characters, more or less. 4 ASCII characters, so 4 English letter characters. And I might be off a little bit, but something of that nature. And what you need to understand is, when you're running these agent harnesses, or you need to run it in a loop, the agent harnesses have some core primitives that are important to understand. So first is the tools, file system, access to a bash shell. There's some opinions that that's why you need it in a full virtual machine or Linux environment, not just very minimized sandbox, firecracker, micro VM. Maybe there's some other CLIs it needs access to. They could be custom, homegrown, bash scripts, whatever. MCP servers, it's connected and access to other things in your ecosystem. Then you have your memory and your context window, so system prompts, retrieval of memory. Maybe there's a bunch of documents indexed somewhere. Maybe it needs to store its own chat sessions and threads, things of that nature. Remember what you were talking about in other times. But the subject of what's deep to understand here is what the model adapter is doing. So the model adapter is how these agents are quickly routing between different models. And it's very key to understand, because I think a lot of people are not properly accepting the value of what an AI gateway is. But before we can get to an AI gateway, we need to understand just some basics as to why this is important to start bringing this growth of an AI world and a growing technocratic society globally, but especially in America, and kind of bring some of this back in your hands. So the model adapter is routing you to the LLM, the large language model. How does it get there, and how do you start getting a bit more control in knowing how this works? So in the demo you're going to see here, I'm going to be routing to a local LLM that's running on this MacBook Pro I'm recording off of, and usually that's just a loopback interface, and it's traversing over my local host. So it doesn't have to leave my machine to go make that communication to my LLM. Most of the time, when most folks are using these large language models, are going over the internet. So they're going over their public internet interface, and usually I just have kind of standard here, like ETH0 is usually that's the IP assigned on your machine, public IP, or one that's joined to your Wi-Fi router. And that's how you're ultimately hitting, api.openai.com, api.anthropic.com, google.com. All your .coms are that's how you're hitting all the DNS resolution. So you can build these agents and very reliably depend on the APIs. I'm not going to say that you can't build products that way, but I felt compelled to make this because as API tokens are starting to get very expensive, I think it's sort of incumbent upon us to start thinking about how do we take some of this in our own hands and not just ultimately be victims in the AI underclass. Uh, if some of you keeping up with that and the memes going around, I think there's some truth to it. And even with the release of Fable 5 being so expensive, $50 per million output tokens, there's a key element there that we have to rein in the cost, rein in control, understand our privacy, understand our security, understand, what can we control, what can we do about it, even though, they're very powerful models. And then we have a private endpoint that you can set up as well. So you could host models yourself. It's not an easy thing if you don't know what you're doing, but there's several inference stacks you can do. Tensor, RTT, VLLM, Ollama. However, Ollama is not really for a distributed cluster. It's kind of a single machine usually. So not exactly recommend that. You probably want VLLM. And I'm forgetting one right now, but anyways, the key to this is how you're routing to the model. Okay, so these are some basic primitives to understand that you want to begin understanding how do you do more of this stuff right here in this red box. Okay, so once you start getting into this red box of AI usage, we start getting more into the sovereignty world of it. So sovereignty, I'm gonna make this extra large. So I'm gonna use some flagrant words. Technocratic sovereignty. Okay. It may not make sense to you. I spelled sovereign wrong. I might have just spelled it wrong again. Okay, no, I'm good. All right, so this is where you need to go. If not, what's going to happen is you're going to be paying for till the end of time. Cloud rent-seeking subscriptions and API costs. Not the worst of the world, but in a world where wages are already compressed, the software is getting more expensive. Remember, AI is just software. You're talking to software. Don't overthink it. Don't emotionalize it. It's just, good software. And there's a lot of animal spirits around it. And it's for rightfully so. It's intelligent software. But this is kind of where we're talking about today. Okay? So for the harness we're using today in this particular demo, we're going to be using Pi. Pi is sort of a minimalist harness. I've been experimenting it with a little more, but between Pi and OpenCode, these are more the open source ones. I highly recommend you check them out. And for this, you can kind of get a basic idea of, you can route through model providers. It has some of the core primitives that are done very well. Start adding your own tool calls, and the reason people do like it is because of how minimalist it is. So like no MCP, just CLIs. So if we go back to here, these agent harnesses can start getting opinionated, and the opinions are how the tools they use, the models, maybe there's some pre-tuned memory, context window, things like that. So today we're going to be using that, and then in terms of my local machine, I'm going to be using Ollama. So Ollama is designed by Meta. It's come out of Meta, sort of as a local inference stack. Pretty easy CLI tool. I'm pretty sure they've written in Golang, and it's a way to run open source models. So there's a lot of Hugging Face models that get support to be run through Ollama, but it's not explicitly always the case. Okay, so Ollama is just an easy thing to do. And maybe in future videos we'll show VLLM and more advanced ways. If I want to pay for the actual clustered hardware, I might actually do that, but we'll decide at a later point in time. So now we'll kind of just jump over to the demo here, and I've already sort of pre-filled these folders. So if I do ls, I have my two folders here: Rust demo, Golang demo, and now what I'm going to do is I'm going to launch Pi with Ollama. So because I'm using Ollama as my model adapter, I'm going to use Ollama to do Ollama launch Pi. It's asking me now for my model I want to use. This might be kind of small, so I'm sorry for you in advance. But I'm going to use this sort of Quen 3.6 27 billion uncensored parameter model that came out of this, I think one of these CS departments. I can't remember at the moment. But why am I using this model? And I want to make a little point about this. So, there's a lot of what's happening with AI where, we're told we're worried about safety. There's a lot of narrative of, oh, it's like a cyber weapon. It's like making enriched uranium. And while I fundamentally disagree that it's that dangerous, it's like, I kind of think of it as like, imagine, back in caveman's time or Neanderthal's time, and we discovered fire. They're like, oh, we need to ban fire. Like, oh, sorry you want to cook your food. Sorry you want to stay warm in your house. Doesn't matter. It's too powerful for you. So we're not going to let you have access to the wood, the tools to spark the fire, create the fire, etc. So I say it like that, and we're all, most of us in this society are grown adults. Even the youth that are getting educated, they're going to grow up to be adults. And like an adult, when you go into the shower and you take a bath, you don't go in the bath with safety floaties on. You don't go into the grocery store wrapped up in styrofoam tubes. You got to deal with the risks of what the world gives at you, and you as a citizen are trusted to make those decisions. This is a primitive of a democratic republic. This is a very basic thing. We have the right to buy guns. We have the right to vote, and these sort of simple things apply equally to powerful LLMs. Okay, so now what we're doing is we're launching Ollama Pi. And I don't know, maybe I can zoom in here. I don't think I'm going to be able to. Okay. Anyways, so we have our Ollama Pi here. Looks like there's an update, but I'm not going to worry about that. I'm going to say I have 2 folders, a Golang demo. I think I just added Golang demo API at Rust demo API, and then I'm going to say in each make a simple hello world API endpoint, and for Go use the standard lib of net HTTP. And I don't do Rust at all. I haven't done really Rust, but just for the sake of showing you can do it with Rust. I'm gonna say Rust, use Actix or Tokyo, I think are the main ones. I'm just gonna say Actix. And if anyone wants to give me crap about it, feel free and teach me why. And again, I'm trying to learn in public here. And then make sure it's a JSON body with a timestamp plus with the timestamp plus epoch. All right, so we're gonna have Pi go here, so it's already gonna work. And just for the sake of this, we can kind of monitor how it'll develop. So it looks like it's doing the planning. It's gonna do its thing and work. And just to sort of ground ourselves, I'm gonna let it kind of do its thing and generate. And we're gonna go back to our diagram. And mainly what we're doing here is our agent harnesses Pi. Pi is mainly accessing your file system in Bash. In this case, that's how it's analyzing my in my Mac terminal here, or Ghosty terminal. And then the model adapter, what I've chosen is this one. But I could host this on another one and just make sure it hits the same endpoint. because it's just it's interfacing with the LLM to do the agentic things. But in our case, we're using this, and that's the part of our demo we're showing here. But again, what matters is starting to get more in this sandbox networking, private networking, local compute, and bringing the cloud to you. Having your own cloud, your own AI. So we can go back. I can start feeling my Mac get hot. I have 128 gigabit of RAM here, and a Mac M5 Max. I just got it new because when Fable 5 came out, I was like, I really need to have at least some decent horsepower in terms of compute to be able to do this. Okay, it's telling me it's done. So let's go inspect each one just at a very basic level. Okay, we got to go main.go here. So let's look at it. Okay, so what it's doing, it's using some of these standard libraries, JSON format, log, NetHTTP, time. It's building a response data object that also has pre-filled JSON support in the struct. We have a hello handler, so when that route is hit, it's going to call this handler, and then at /hello, it's going to use this port, and then it's going to log if anything breaks, serve that port. Okay, most part looks good. Pretty simple program here. Okay, so I'm going to quit. So now if I do go run main.go, Go is listening, so it successfully one-shotted this very infantile API. And then now if I go to localhost 8080/hello, I get my payload. So timestamp is here. If I refresh, looks like it's not giving me a different time, but that's okay. It's not the point of this video. And then we go back. So let's go look at our Rust demo API. Again, I want everyone to laugh at my Rust. I really have not done much Rust stuff at all, other than knowing all the drama Bun rewriting into it in 8 days because of Claude. But arguably helping them with some of their seg faults and memory leaks. I haven't heard a good engineering reason as to it's worse yet. Maybe it will do worse. Maybe there'll be something big that happens, but for the most part, it's just it's apparently doing pretty solid. So in this particular server, and I'm just going to kind of read through its pseudocode. So it's deriving a serialize. I don't know what these are. Chrono, local. Not sure what these are. I assume there's just some libraries and cargo crates. Okay, so looks like it's a decorator of this struct. So similar to Golang that you can see here, or in the past one you saw. So doing local now, it looks like that's summoning the time. Oh, okay, yeah, chronometer. Maybe that's what it is. Okay, and then it's doing now to RFC, now to timestamp for the epoch, and then HTTP response. I wonder why they do this kind of. It's like a piping a path or something. Okay, so and then response declares the response. Then it has a pointer to this response with this amp, and it's decorating at Tokyo main. Server is running. Run the server. So for this route, use hello, this function that gives us responder output, which I guess is part of this library. Okay, so I have no idea if that's good or not, but I think what's cargo run. Okay, now we're going to do cargo run. think it might have to get some stuff. So we're getting some dependencies here. And man, with all this supply chain attack stuff, this used to feel cool. Now I feel like vulnerable. But anyways, so okay. Now what we're gonna do is we're gonna go here, and then it looks like the same thing. Okay, so I just want to verify that my processes are done. So ls. So we're gonna listen to what and inspect what processes are running on 8080. So it looks like my Rust demo is okay. Cool. So I'm gonna kill it. All right, and then I'm just gonna make a quick edit here. Oh crap, what did I do? Oh, it's a folder, that's why. I tried to vim into a folder. Don't do that. Okay, vim main.go. We're gonna change it down here. I'm gonna change my port to 8081. Okay, so that's listening there. Okay, 8081. Hello world from Pi agent go API hashtag learn in public. That's sort of my moniker for this stuff. Okay, so I'm just manipulating that string, not expecting anything major there. Okay, if I run this again, yep, okay, nothing's running, very good. Okay, now if I go into my Rust, so I got two terminals here, it might be hard to see, but vim, so now if I go to cd source, vim this main.rust, okay. Keep this one on 8080. Hello world from Pi coding agent hashtag learn in public. Pi coding agent. I don't even remember what I said on the last one. Rust demo. Okay, so I'm just manipulating basic strings with Vim. Okay, so now we're gonna run these again. So we're gonna do what was it? Cargo run. So cargo run. It rebuilds it. Okay, and then I'm gonna do go run main.go. It's gonna run it as well. So we're listening 8081, 8080. So now if we do 8080, we got a different payload. So Rust demo, 8081. We'll switch to the other one. Okay, so that sums it up for this video. I hope it was useful. If there's any sort of particular subjects or you want me to do, or you want to learn in public together, just leave a comment, get involved, and let me know what you want to see. Have a good day.